So in this example, we're going to look at how equilibrium can change with an extra variable here. In this case, it's px, so maybe the price of some input for the quantity supplied. So let's begin by starting to try and solve for equilibrium, and we'll see we have this px term which equilibrium depends on. So solving for equilibrium, you said qs, qd equal to each other, which turns out to be 2p minus 5px equals 60 minus 4p. And then just like regularly solving for equilibrium, we can bring this p to the other side, and then 10 over, and this 5px over as well. And dividing by 6, we get 50 over 6 plus 5 over 6 px. So a little bit ugly, but we can find out that the price in equilibrium equals 50 over 6 plus 5 over 6 px. So how does p change with px? We can see that anytime px increases by 1 unit, p will increase by 5 over 6. So that solves that part of it. How can we get this q value? So we're going to have to plug in this p we found for qs or qd. So let's just plug it back into qs. So we'll get qs equals 10 plus 2 times 50 over 6, that's 100 over 6, minus, or 2 times 5 over 6 px, so that's 10 over 6 px, so that's the 2p term in the middle, and then minus 5 px. And then this qs will be equal to qd, so it'll just be the exact quantity in equilibrium, because we've found this p that occurs when qs and qd are equal. So we can simplify this further. 10 is really 60 over 6, so go 160 over 6 plus 10 over 6 minus, this will be 30 over 6, so actually minus 20 over 6 px equals q. And now we can tell that q changes by minus 20 over 6 every time px increases. Again, you can look at this and tell it, or you can take the derivative. So how does q change when px changes? So we can just tell this is minus 20 over 6, because this is a constant, so it'll be 0 when you're taking the derivative. So every time px increases by 1, q will decrease by negative 20 over 6, which really simplifies to 10 over 3, negative 10 over 3 we'll say. So that's how equilibrium p and q change with respect to px.